How's everybody doing today? My name is Danny Zimmerman. I'm a senior software developer on SAS Studio team. I've been at SAS since 2011. Been working on the SAS Studio project since the beginning of the project. And most recently, I've been working on a series of data step functions to execute Git operations so that SAS Studio could build a Git UI on top of those functions. My paper was called SAS Functions to Drive Source Control with Git. Today's agenda, we'll do a quick overview of what Git is. We'll talk about why the functions were developed, and then we'll talk about functions themselves, starting with functions that interact with the remote repository, functions for staging and committing files, and then we'll hop into functions for retrieving the status, the history, and file differences. And then we'll wrap it up with some functions about branching, and then conclude and open it up for questions. So what is Git? Git is an open source distributed version control system. It consists of two different types of repositories, a local repository on your machine for your direct use, and a remote repository hosted on a server or a service such as GitHub. To the right is a little high-level diagram of what it is. Near the top, you have your remote repository hosted somewhere. And down on your computer, you have your workspace with all your files, and then your local repository that keeps track of all those files. So why were the functions developed? First and foremost, version control adds tremendous value to any workflow. Being able to version your files, keep track of any changes, revert back to changes, is it's just a powerful thing to have in SAS in development, and it just helps. And also the ability to share and collaborate with users easily without stepping on each other's toes. And then version control also, Git itself keeps your code safe. You have two different locations where your code is. If your hard drive just dies on your local repository on your local machine, you lose all your local files, you still have the remote repository that has them all. Secondly, user requests for version control in SAS Studio. Since we released SAS Studio, we've had people ask, how do I version my files? How do I collaborate easily with other users? And we had to figure out how to do this. With SAS Studio being a hosted solution, we had to get around networking obstacles. SAS Studio might be hosted on one server, the mid-tier, and then the workspace server is on a completely different server. So how do we get through all those obstacles without having to deal with configuration for networking and permissions and security? Our solution was to build Git into the SAS platform. We did this by loading a third-party Git library into SAS and essentially made a Git API in the SAS language. With 9.4m6, we released 24 Git functions. Each of these functions has a prefix of gitfn _. So let's take a look at some of the functions. The first set of functions I want to talk about are the functions that interact with the remote repository. These are functions that include, with 9.4m6, we include 3 functions that interact with the remote repository. First function is clone. This allows you to copy the remote repository down to your local workspace and creates a copy of that remote repository. Pull. This function fetches any changes from the remote repository and merges them into your local repository. And then push. This will essentially just publishes any of your changes that you have committed to your local repository to the remote repository so other users can access them. Each of these functions support HTTPS and SSH networking protocols. So let's go ahead and take a look at some examples. So the first set of examples deal with HTTPS. These are data step functions. So you have to have your data step. The first function is clone. You have to pass in the remote repository path or URL. the location on your computer where you want to store your local repository, and then your username and password, your credentials to access the remote repository. Pull and push, they already know about the remote repository, and so all you need to provide is the local repository path and then the credentials. The next set of code I want to talk about is SSH versions of these functions. So again, you have clone, and the only difference is you have 2 extra parameters, the path to the public and private SSH keys, and you notice that the username is Git. It needs to be whatever comes before the @ sign in the URL. The next set of functions I want to talk about are functions for staging and committing files. In order to share and version your files, you have to go through a process of first modifying or adding files to your local repository, and then you have to stage them or add them to the index, and then commit them to the local repository. So the first function is the index add function. You can add multiple files to the index from 1 to n number of files. So you're taking those files and telling Git that you want to include these in the next commit. If you stage something that you do not want to include in the next commit, you can always remove it from the index. And again, you can unstage 1 to n number of files. And then you have commit. And this will commit anything that's in the index and makes a snapshot of your current file system and creates a commit of it. So anything that was changed in the index will be included in that commit. So let's take a look at some code. So the first function is index add. You can see that we pass in the local repository path. We pass in cowboy.sas, which is it's the file path relative to the local repository. So cowboy.sas is in the root of my local repo, and it's a new file, so we have to include the status in the index.add function. And the second file is cars.sas, and it is a modified file, and it's in a subfolder, so you can see that we have a subfolder. Index remove is similar to index add. You just do not need the status of the file. And then commit, you need to pass in the local repository path. Head is the update reference. 99% of the time it's going to be head, so you're committing to the top of the repository. Author name, author email, and then your commit message. The next set of functions is status, history, and file differences. I included all 3 of these together because they follow the same design pattern. They all have each set has 3 functions: a function that generates a data structure in memory and returns the count of objects that was generated, a function to access properties of that object, and then functions to free the data structure from memory. SAS does not have garbage collection, so you have to free your memory. So let's take a look at status. The repository status returns any files that have been modified and whether they've been staged for commit or not. So the first function you would run is status. It like I said, generates a data structure in memory and returns a count of objects that were generated. And then you have the status get function. Allows you to access properties of a status object. There are 3 properties for each status object: a file path that's relative to the local repository, whether it's if it's modified or new or deleted, and whether it's staged for commit or not. And then status free, which just frees the data structure from memory. And this is an example of the code. To the left, we initialize some variables. We run the status function, and we get the count back, and we start looping through. And then we can access each property. And to the right is the example output. So you can see cowboy.sas was modified, and it's not staged. And demo.sas was deleted, and it's not staged. Next set of functions is repository history. The repository history contains a list of commits that have been committed to the repository. It follows the same structure as status, a design pattern. You have commit log function that generates the data structure in memory and returns the count. The commit Git function that access properties of the commit objects. There are 6 properties for each commit object: commit ID, the commit message, the commit author and author email, a timestamp, and parent IDs. So you can use that to iterate back through the commit history and see how did this commit get generated, and the commit free function. Let's take a look. As you can see, it's the exact same type of design pattern, just you're accessing more properties and different function names. Near the bottom is the example output. The commit ID is crucial to other functions. So you can use those commit IDs for parameters to obtain like file diffs or create branches. And let's go ahead and take a look at the file diffs. File differences, you need to have 2 commit IDs to be able to generate file differences between the commits. You have the diff function. Again, generates the amount of diff objects. The diff get function, which allows you to access the properties, and there are 3 properties for each diff object: the file path, the diff content, and the diff type, which is the status of the file when it was committed. And then again, the diff free function to free the memory. And here's an example. As you notice, you see that there's extra parameters. And those extra parameters is the commit IDs. So you would submit the older commit ID and then the newer commit ID, and then it generates a diff of those two, between those 2 commits. Down below you see example output, the file path, which is again cowboy.sas. And we return the diff content as JSON, because we get the diff content back to us in lines. And so we need to let the users know that this might be a header line or addition line, context line, so we package it up in JSON. And this file was added during this commit. Next set of functions I want to talk about are branching functions. There are 4 branching functions included with 9.4M6. The new branch function, which will creates a branch at the given commit ID. Delete branch function, which deletes a branch. The checkout branch function, and the merge branch function. Let's take a look at some code. So the new branch function, like I said, requires a commit ID. You need to pass in the local repository path, the commit ID, and then the name of the branch. Delete branch, you just give it the local repository path and the branch name, and it will delete it. Checkout branch, same thing as delete branch. And then the merge branch function has 2 extra parameters, where the author name and author email, in case the merge ends up in a merge commit. So you can know who did the merge. So in conclusion, we talked about Git and the value of version control. The implementation of the functions was driven by SAS Studio. We highlighted functions that interact with a remote repository, functions for staging and committing files, functions to obtain the status, the history, and file differences, and functions for branching. For more details, please read my paper and come visit me and the SAS Studio team at the SAS Studio booth. Any questions? So the question was, will it work only in SAS Studio? So these functions were shipped with 9.4M6. You do not need SAS Studio to run the functions. These are base SAS functions. They were created so we could create a Git UI in SAS Studio. So the question was, if I had an older version of SAS, could I import, like backport these back to another version? We do not have that capability right now. You would have to upgrade to 9.4 M6. The 9.4 M5 has some of the functions in them. They were not documented because one, the third-party Git libraries were not shipped with M5. They are shipped with M6. And they still are, in M5, they were not very refined. They're still in development process. We have to get it into the versions when we can. So we did not document them.
Will this be available in VIA too?
Yes, this will be available in VIA. It will be in VIA 3.5 for sure. And there will be 10 additional functions. I've already written 10 more functions for VIA 3.5.
Okay. When you say the local repository, the repository is actually on the SAS server, right?
Yeah.
The workspace server.
Yeah, and that was one of the main reasons why we had to create the functions, is because we needed to get to the SAS workspace server without having to do extra configuration with like the SAS mid-tier. And so wherever SAS lives, the user files live. And so we could just get past all of that with the functions.
Thank you.
Yep.
A basic question before my real question. 9.4 M6, is that available as standalone, or is that only in VIA and with Studio?
So 9.4 M6 is the latest version of SAS 9. So if you order SAS 9, you will get 9.4 M6.
Okay, great. And then the follow-on is, it sounds like this only has the ability to set up a local repo on the servers as opposed to locally, like if you're interacting with EG and you want it to get on your local machine, or like a network drive that's not necessarily on board the SAS server. Is that pretty good?
So sorry for cutting you off. Wherever your SAS lives and you have these functions, you will be able to create a local repository where SAS is. So if you have SAS installed on your box and you're running EG, you might not have the UI components in EG yet. That's actually in the roadmap to make a UI in EG using these functions. But you could use the functions to do Git stuff in EG. And
just the follow-on comment I'll make is, regardless of whether these are being used for development, I'll say that if a institution has GitHub, I have to imagine this would work great as a deployment solution to grab the most recent. So thank you.
Yes, thank you.
Just real quick question.
Sure.
I think I know the answer, but I'm assuming that you don't need a separate Git installation on your SAS server. It comes like nested with the SAS installation, right?
So yeah, we ship a third-party Git library. It's called libgit2 with SAS.
Okay, that is the installation.
Yep,
okay,
cool. You do not. Your users do not need to have Git installed.
Thank you.
Yep. Any more questions? Can you use the mic, please?
So one last question. What happens when you are trying to committing something and you have a conflict? So
what we do is we have conflict labels. So if you try to if you have, say, I'll always go back to cowboy.sas. If you change one line of cowboy.sas and you commit it, you won't run into any conflicts there. But when you pull it down from the remote repository and another user changed that same line, what will happen is SAS Studio will say that merge conflicts exist. You need to check your index. And then in the functions, they'll put in the log, they'll say there are merge conflicts. And you would go back to your file and you would see conflict labels, and it'll wrap the code of your code and say this was your local code. And then you'll have conflict labels that wrap the remote code and say this is the code that came down from a remote. And so you'd have to manually resolve your conflicts.
So did you incorporate it as well, Git merge or not?
Into what?
Did you incorporate it as well, Git merge?
It's in merge, yes. So
no, but is it also in this, did you make the function for that or somebody has to do it manually?
So pull is essentially a fetch from the repository and a merge. And then the other merge function we have is merge branch. And those are the two where you would run into any merging issues
Okay.
and conflicts, yeah.
Thank you.
Yep. Any more questions? Thank you.